All right, we've been looking at linear equations. We've been looking at systems of linear equations. Now we're going to look at things that are not equal. So linear inequalities and systems of linear inequalities. So things are not always equal, and we'll look at what happens with that. When you have a linear inequality, so we've got, in this case, y is less than 2x plus 1. You have a linear inequality, you're going to end up with an infinite number of solutions. There's not just one solution. There's an infinite number of solutions. We're going to look at how to deal with that, but we're going to start by simply testing. They've given us one solution, and they're asking, is this actually a solution? Does it work or not? So we're going to substitute. We're going to test it. Let's see if it works. X is negative 2, y is 4. So y is 4, x is negative 2. Let's see what happens. 2 times negative 2, negative 4, plus 1, negative 3. So the question ends up being, is 4 in fact less than negative 3? No. No, 4 is not less than negative 3. Not a solution. Okay, that's not so bad. Let's do another one. I'll do one with you here. So we've got, again, another inequality. Y is greater than x minus 4, and I've got a solution. I want to know, is this a solution? Y is 1, x is 3. Let's see, 1 is greater than negative 1. Yeah, 1 is greater than negative 1. So yes, that is a solution. Now, they could have picked a different one. Let's say if instead of y being 1, let's say y was 2. So y was 2. Is that a solution? Yeah, 2 is greater than negative 1. How about if y was 3? Yeah, 3 is greater than negative 1. Y could have been 4. So there's lots of different solutions. There's an infinite number of correct solutions to this, and they just pick one and are asking, is this one a solution? And yes, it is. So for these two right here, A and B, I'd like you to pause it, take a minute, see if this is a solution to that linear inequality. Assuming you paused it, I'm assuming you tried it on your own. For the first one here, A ends up being that no, that is not a solution to that linear inequality. And in this case, yes, B is a solution. If you did not get those, or if you're going, no, you're wrong, watch the linked video and see how it's set up. Let's move on. The little more difficult stuff. Testing it, yep, great, but now let's see if we can find those solutions. There's going to be a lot of writing here. If you want to use your notes to the best of your ability, to make sure that you are studying things, to make sure that you understand this material, take the time to write this down. Don't just say, I'll look at it later. No, you won't. Pause it, write things down. If you need another piece of paper, use another piece of paper. If you want to use the margins, you've got lots of white space on these notes page. Use that space. But I want you to write these things down. This will really, really help you. Let's talk about the green and purple shaded regions here. Like I said, there's an infinite number of solutions. And so if you see something like y is greater than some line, and go back here, right here, the second equation, B. It says y is greater than x minus 7. What that looks like, or what that's saying, is that when you have that greater than, y is greater than, it's above that line. Every y value that is above that line, x minus 7, is a solution. That's going to make more and more and more sense as we do some examples. But that's what we're saying, is that when y is greater than this line, any y value above that line is a potential solution. If you have y is less than, or y is less than or equal to that line, x minus 7 or 2x minus 5 or 7x, whatever. If it's less than that line, we're going to shade below the line. And again, that will make more sense as we do some examples. You kind of see how that fits together. But we need to talk about how we know it's above or below. And so we shade above the line if y is greater. We shade below the line if y is less. Now for those lines themselves, we've got a red line there and a purple or a blue line. If y is equal to, if y is less than or equal to, y is greater than or equal to, we're going to draw a solid line because it could be equal to that line. If y is simply less than or greater than with no equal sign underneath it, we're going to do a dashed line because y will never equal that line. It'll get really super duper duper close to that line, but it'll never actually equal that line. It's kind of like when we did a closed-in circle and an open circle. When it was a closed-in circle, y could equal that number. If it was an open circle, y will never quite equal that number, but it'll get really, really super duper close. I'm assuming you paused it or ignored me as I was talking and wrote things down. If you didn't have enough time, pause it and continue writing. Okay, here are our steps to solving and graphing a linear inequality. We are going to do step 1. We're going to get y all by itself, slope-intercept form, y equals mx plus b. Step 2, we're going to graph the boundary. We're either going to do a solid line or a dashed line. We're going to graph the line like we normally do, except with a solid or a dashed line, depending on if it's equal or not equal. And then we're going to shade. So let's do an example. I'm going to start with step 1. I'm going to get y by itself. In this case, we're good to go. Y is all by itself. Y equals mx plus b. We've got our slope-intercept form. Now I'm going to graph it. Now I notice that it's y is less than or equal to. And so if it could be equal to, it's a solid line. Okay, so I'm going to make a solid line, 2x minus 3. So the y-intercept, -3. It's a solid line, and I'm going to do a rise of 2, a run of 1. So I'm going to graph that line, there we go, with a solid line. Now I'm going to do step 3, I'm going to shade. So let's talk about what this statement says. Y is less than or equal to 2x minus 3. 2x minus 3, that's this line here. That's the line, 2x minus 3. So that's the line we just graphed. This says y is less than that line. So here's my y-axis. These are all the y values, all the way down here. These are all y values. Those are all y values. My statement here says that y is less than the line. So this y value here is not less than the line. It's not less. It's not underneath. It's not below the line. So if y was -1, the y-intercept is -3. So -1 is not going to be greater than -3. If I look at y being -4, well, -4 is less than this y-intercept of -3. So it is less than that line. So this is a solution. Let's look at maybe this point right here. That's the point, 1, 2, 3, -1. 3, -1. If I put that into my equation up here, I have 3, -1. That was my point, 3, -1. Let's see if this is a solution. 2 times 3 is 6 minus 3. Is 3 greater than or equal to -1? Yeah, that's a solution. How about this point right here? We've got 3 positive 2. So again, if I substitute into my inequality 3 positive 2, 3 positive 2, substitute that in, I get 6 minus 3, again it's 3. And 3 is greater than or equal to 2. So that is a solution. Let's pick a point maybe right here. We've got -1, 2. I think you know what's going to happen, but let's just work it through. So I've got -1, 2. So -1. There we go. So if I solve this and check, is -5 greater than or equal to 2? No, it's not. So this is not a solution. In fact, any point out here will not be a solution. It won't work because y is not less than that value. So I'm going to shade below the line. Everything below here is shaded. It doesn't have to be every single thing shaded in, but that's pretty good. So that's how we solve these. I went through that really slowly. I'm going to go through the next one a little bit faster. Okay, I got to get y by itself. I'm going to graph this equation. I got to get y by itself. So I'm going to minus 5x from both sides. We get 2y greater than negative 5x minus 8. Divide everything by 2 to get y by itself. To isolate the variable, we've got negative 5 halves x minus 4. Now I can graph it. I notice that it's y is greater than, but not equal to. So y will never be equal to this line. So I'm going to do a dashed line. I'm going to say that negative 4 is the y-intercept. Rise of negative 5, a run of 2. So normally I would go down 5 and over 2, but I don't have quite enough room on my graph. So I'm going to go up 5, 1, 2, 3, 4, 5, and to the left 2. It's still going to give me a negative slope, which is what I should have, but it's not going to go off my graph. So there we go. Negative 5 halves x minus 4. And of course, now that I've done that, I realize I didn't use a dashed line, because y will not quite equal that line. Now it says y is greater than negative 5 halves x minus 2. So I'm going to shade above the line, because every y value above that line is a solution to that inequality. And that's it. That's how we graph it. I say that's it. It's so easy. Come on. Oh, get y by itself. So the steps here, get y by itself, get a slope-intercept form, either solid or dashed line, depending on if it's equal or not, and then we shade. If it's y is less than the line, we shade below the line. Y is greater than the line, shade above the line. Give these last two a try. I'm assuming you paused it. I'm assuming you tried it on your own. The first one here, I'm just going to graph it. I'm not going to go through all the work of seeing where it goes. But we should have an equation like, or excuse me, a graph like this. And shade it up here. Go. And the next one then. The next one. Oh, and if you didn't get that graph, sorry, if you didn't get that graph, watch the video and see how it's done. Second one here, again, I'm going to graph and go. Oops, excuse me. Go. Okay, double check that. Yep, that is correct. And I'm going to shade down here. So if you didn't get those two graphs, make sure that you watch the videos, see how it's done.